on. I can see. Okay. Okay. Interesting. All right. Okay. So, this is the AI and virtual robotics track. And so now we are going to be exploring robots. Okay, we'll be exploring robots and we'll be exploring AI, right? Artificial intelligence. Okay, so now I would like to ask a question. I'm sure many of us have heard the word robot. All right. When we say, I will show you a robot actually, but then when we say robot, so I want to know what your perception of a robot is. So anyone at all. So I think this is the correct first step we need to take. Let's be sure we all know what a robot is. Okay. So anybody at all. So when we talk about a robot, what exactly is a robot? Let me just say what you believe a robot is. Okay. All right. So I'm seeing, okay, Jane said a robot is Jane said, hold on while I open the okay, something that can move on its own. All right, that's interesting. That's interesting. Okay. Chizzy said the robot is sometimes a humanoid machine that carries out tasks. Okay, that's also interesting. All right, it's something that follows others. Okay, okay, beautiful, beautiful. All right, so can I have one more person tell me what a robot? A helper. A robot is a helper. Interesting. Okay, something that can have human-like traits, okay? Something made out of iron, made for lots of things. A robot is an artificial intellectual powered to able to perform almost everything. Okay, okay, that's interesting. A robot is a machine that helps human. A robot is a machine that carries out tasks automatically. Okay, you all have answered quite beautifully. You all have given quite interesting responses about what a robot is. Okay, now that brings me to, and I'm not saying anyone is wrong or anyone is completely wrong. Okay, so all I'm saying is everyone has answered beautifully. All right. Okay, so now that brings me to the second thing. Yeah. All right. Now, your mobile phone, for example, I have a mobile phone here. This mobile phone, is this a robot? Can we say that this is a robot? Can I say, oh, can we say, oh, this my nice mobile phone here is a robot? Can we call it a robot? Someone should tell me. Based on you're answering yes, okay, beautiful, beautiful, okay. So that means even my laptop is a robot. Because someone answered by saying a robot is something that helps people, which is actually interesting. Okay, so even my laptop is a robot because it helps me to connect to this is about 20 people right here. So connect to 20 people, even when we are not physically meeting. When we say robot, a laptop is a robot. Okay, someone is answering by saying technically. Someone is saying no, we can't say. Okay, robot is a device. All right. Okay. All right. So, actually, a mobile phone just any electronic gadget doesn't automatically qualify to be called a robot. All right. So what does that mean? It's not all electronic gadgets that you call a robot. For example, a mobile phone. I'm sorry, but this is not a robot. Yeah, it's a smartphone, it's a smart device, right? But it is not a robot. So you will see what makes an object to be called a robot. All right, shortly. Okay, a laptop is not a robot. All right, a laptop is not a a car unless it is a self-driving car. You can't call just about any car a robot. No, it doesn't work like that. All right. So now, what makes a robot a robot? Right. Now there are 5 key features, all right, that makes every robot a robot. So number one is what we call sensor. It has to have a sensor. All right. So let me explain what sensors are. Okay. So look at your eyes or touch your eyes. All right. Touch your ears, your nose, your mouth. These are sense organs. All right. So in robotics, when we talk about robots, they have their own sensory devices or components which are analogous or similar to the human sense organs, right? So, for example, in a robot, you talk about a camera. Robot could use a camera to have a visual understanding of the environment around it, right? A robot could have um, a pressure sensor, all right? A robot could have a temperature sensor. So there are various sensors, all right? So sensors are basically devices that a robot uses to interact or gather data from the world around, from the external environment. All right, so it's important to note that not all sensors collect data externally. Some sensors also collect internal data. For example, you can put a sensor in a robot that allows it to monitor its battery level. All right, so whenever the battery level goes below a certain amount, it triggers a response. All right, so that could be a sensor as well as an internal sensor. So every robot must have a sensor, right? Now let's go back to our friend, the smartphone. Now, this smartphone actually has a sensor. All right, it has a sensor, but then having just sensors alone is not enough to be called a robot. Now let's look at the um things that make a robot a robot. Number one is sensor. I've mentioned that. The second thing is actuators. Robots should have actuators, and that is where your PC and your mobile phones get disqualified. All right. They have sensors. For example, this phone has an IR sensor somewhere here. All right. So it has various other sensors. It has a gyroscopic sensor inside, which enables it to sense balance and stuff like that. But then it lacks an actuator. All right. So what is an actuator? An actuator is more or less component that allows a robot to move. All right. A robot should be able to move. It is very important. And when we talk about movement, there are various kinds of movement. There is rotational movement, there's linear movement. A robot should be able to move in some way, in a way. It should be either the movement can vary, it could be manipulating objects, it could be moving objects or translating objects. The method or way by which the robot move can vary. It could have a conveyor belt, conveying things. It could just be, so it could work physically like the way a human being works, right? There should be a level of movement. And then looking at this phone, there is no form of movement in it. It is just there, right? So because it lacks actuation, all right, it doesn't qualify to be called a robot. So other features of robots include the power. The robot should be powered. The robot should be, they should have, we've mentioned, they should have sensors. it should have the actuation, it should have the power. Then a robot should also have a level of computer programming. All right, a robot should know what to do. It should be intelligent. So there are various levels of intelligence, right? So there are various levels of intelligence. So intelligence simply means knowing what to do, when to do it, and how to do it. That's what intelligence means. This is the simplest possible definition of intelligence ever. All right. Knowing what to do, how to do it, and when to do it. That's intelligence. All right. So a robot should be intelligent to an extent. All right. There are robots, even if they require human assistance, the human assistance should not, a human is not expected to assist a robot all the way. 100% assistance. No. Whenever a robot starts needing 100%, that means it's broken. It is no longer a robot, because a robot is meant to take decision on its own, right? Certain decisions, at least, on its own. All right. So that's talking about intelligence. A robot should have a framework that puts it together. There should be a framework that puts it together. Um, then, so we've mentioned the sensors, we've mentioned the actuators. Actuators are things like motors and the rest of them. Then we mentioned intelligence. The robot should be intelligent, should possess a level of intelligence. We've mentioned framework, right? A robot should have framework, and then we mentioned power. All right. So a robot should be powered. All right. So there should be a source of energy powering the robot. Okay. So now let's yeah, beautiful. Let's continue. So let's take a peep at what we have. Okay, so I'm going to show you one a physical robot actually something actually made. All right. So that one is physical. All right, it's physical. Okay, so I'm going to share it with you shortly. Okay, currently pulling up my screen. Okay. All right. Okay, so now I'm going to show you something that looks, yeah, let me just show you. Okay, so I'm going to play a video. All right. So, all right, just look at this. Okay, so I want to. All right, so the video, it's okay. Let's just see. Sorry for the delay. I really apologize. All right, so here is the video. So I'm going to share something else. Okay, so look at this. Please let me know if you can see my screen. So I'm currently playing. Okay. So I just want to
say that I want to make the car to approach the camera. So that it approaches the camera. So to move backwards, so you move backwards. So now to turn, you want the car to turn left. Okay, so I'm actually considering that it's facing the camera right now. So you want the car to turn left. Okay, so what I do is I click on this button like so, it turns left. So that button is for sharp turn. So we want it to turn sharply to the left to use that button. So you want it to turn sharply back to its original position. You use this button. So it turns sharply. So if you want the car to turn slowly towards the left, you use this button L1 here. So use L1 here. Use L1, this one. So you want it to turn sharp. You want it to turn slowly. So that makes it turn slowly. You want to move back. You want it to turn slowly again. You want it to turn slowly again. Use this button for it to turn. So you can see the car is working perfectly fine. So you can see that the car is working perfectly fine. Okay. So now, now let's turn on the lights. Let's blink one of the lights. I use this button. Okay, so to blink the other light, I use this. Now to switch both lights on, I use that button, the triangle button. Okay, so you can see that the project is such an epic. An amazing project, and this brings us to the end of this tutorial series. So I hope you had a good understanding of how to make this car. So thank you very much.
All right. Okay. We can still hear me, right? Okay. So now, as amazing as that project might have been, so let me just explain that was a remote controlled system, right? So basically, I was using the control pad so I had to interconnect the control pad, and I was using it to control the device. You could see there, using it to turn on the lights, using it to turn left, turn right, and stuff like that. Okay, so that's one of the things we do in robotics. We do things like that a lot in robotics. But do you know that as amazing something like how many of you would like to learn how to do something like that? How many of you would like to learn how to do something like that? Okay, I can see, yeah, I can see Chidi, I can see Cheesy, yeah, beautiful. Yes, I'm sure you would like to do things like that. Lovely. And I'm sure you also like to also get to the level of making flying objects like drones and stuff. Those are things we do in robotics. Okay. Now, do you know that as beautiful as that thing might have seemed to you, right? Now, we cannot really consider it to be, yes, that is a product of robotics, but we might not really consider it to be a true robot because it lacks the intelligence, right? It cannot take decision on its own. So I have to control the device wherever I want it to go. When I want to turn left, right? So a robot is beyond that. right? Yes, you can control a robot. Some robot can be controlled, but you don't control it 100% of the way. There should be little or no human supervision. All right, there should be, and there should be a level of intelligence, like the robot being able to. It's called autonomy. The robot being able to take decisions on its own. Yes, about that. This is an upgrade. So I don't know how many of you can see what I'm presenting right now. So this is an upgrade. All right. I really apologize. I had to dismantle it because I was working on a project recently. So I had to dismantle it. I had to use um the the microcontroller here for something else. And I was not really able to um put it back. I've not finished coupling it back, right? It requires some steps actually. Okay, so this is an upgrade to it. So this one qualifies to be called a robot. This is an actual robot, right? Now it can take decision on its own. It can make its own decision, right? Actually, it has two modes. If you want to operate it the way you saw in the last video, the video I just played, you can do that, all right? Then you can also click a button and it becomes fully aware of its environment. So to an extent, it can be aware of its environment. So you can see this is a sensor. It's called an ultrasonic sensor. All right. Okay. So this is called an ultrasonic sensor. All right. So what happens is that the sensor is able to detect objects around. Okay, so it's able to detect objects around. So this robot basically is a robot that is able to navigate obstacles without ever bumping into any obstacle, right? So it's more like a delivery robot. You place what you want to deliver right here, and then it will navigate around obstacles. It will never bump into the obstacle. So that's what these sensors are for, right? So it measures the distance of the obstacle. It does that very fast, measures the distance, and then just before bumping into it, it will circumvent the obstacle. Okay, I can see someone's hand raised. Okay, John. Yeah, you want to ask a question? Okay. All right. Okay. So I saw a hand raised. All right. So can you see what is currently displayed well? Can we see it well? We can proceed, right? Okay. All right. So now so in this AI and robotics track, all right. So we'll be dealing with robots able to sense, able to think, able to move. Remember the actuation I mentioned, and able to respond. All right. So it's able to, based on what it senses, is able to act. So the action now means taking decision. All right. And it can involve movement. Okay. So now I'll come back to this robot again. I showed you. Okay, so I'm going to all right. So do I have any question? Do I have any questions? Sir, do I continue?
Yes, sir. Proceed, sir.
Okay, sir. All right. All right. So now so now this is the upgrade, all right, of the intelligent robots, like an upgraded version of the video you saw. All right, so the whole body has just been removed. Okay, all right. So now basically this robot was intended to be applied in healthcare facilities. All right. So imagine a hospital or a pharmacy, for example, where everybody is busy, right? You have the doctors attending to patients, the nurses helping the doctors out. So imagine integrating a robot in that environment. And that is exactly what this robot is built for. Okay. So basically, it's a delivery robot, all right? So you place the item you want it to deliver, you place it right here at the back, all right? Or it can train something like a trolley, you place it right there, and then you watch the robot move to the ward, right? To the exact ward you want it to move without ever bumping into obstacles. All right. So the obstacles, whether they are moving obstacles or stationary obstacles, it doesn't matter. The robot can navigate its way around without ever bumping into obstacles. So this actually has a motor here, so it can mimic human movement. So you can see there's a motor here that allows it to turn either left or turn right in order to have a full visual understanding of its environment. Okay, so it can turn left, it can turn right. So it scans left, scans right, and finds the obstacle-free path. Okay. So that's the idea of the robot. It basically helps transport healthcare materials to different hospital wards. All right. So that's what the robot does. Okay, but then how is this possible? All right. So there is no magic about it. It's actually very, very possible. All right. So now we want to quickly look into it, quickly study it, have the understanding. All right. So have the understanding of how it works. So now, what is it doing? We want to understand that. How does it even move? We'll be looking at that. How does it know where to go? What decisions might it need to make in order to be able to successfully carry out what is expected to do, which is to deliver healthcare materials to the correct wards, all right? Navigating around obstacles, making sure it's delivered to the right ward. Okay, so now look at this. Look at this. So how does the robot know what to do? All right. So now the question there is, did the robot decide everything by itself? Did the robot decide everything by itself? All right. So of course not. Right. So basically, the robotics engineer, like yourself, prospective robotics engineers, you are the ones that give it instruction on what to do. All right. So you give it instruction on what to do. So this instruction will be stored in the memory of the robot. So you are like saying, hey, robot, whenever you see any obstacle, all right, although we don't use plain English sometimes, we use programming languages, which are languages that computers understand. Okay, so we write instructions, store the instruction in the memory, and then watch the robot execute them automatically. So that's just the idea. So someone has to give it instructions. So this is how it knows when it's expected to move. This is how it knows where it's expected to go. And then when changes happen, it knows the right way to react to the changes. So instructions are very, very important. Robots actually need instructions. Okay. Now, there is a difference between instruction and control. So you give instruction and watch the robot take decision based on the instruction you've provided. All right. Good. Now, same robot thinking. Okay, so same robot thinking. Now we've seen that this robot I've shown you now. So this robot I've shown you now, this one is designed, right, to function in hospitals. But then, do you believe that we can also extend this robot to study our environment and to help keep our environment safe? Right. So now, when you look around, you find various problems around. Okay. Am I audible enough now? All right. So I believe I'm audible enough. Okay. So I'll carry on. So I was saying beyond the hospital environment, you can also extend the robot to be useful in our environment. All right. So there are a lot of problems in the environment that needs to be solved. All right. Different waste materials scattered everywhere. Who collects them? All right. And sometimes it could not be properly collected. Sometimes you have shortage of humans who are collecting them. I mean, these days, most people prefer to work in offices and do more important things, right? Now, how about having this kind of robots? How about extending its ability by putting a kind of arm that can grab these wastes, or putting a kind of suction that can suck the waste and stuff like that in order to keep the environment clean and hygienically safe? Of course, that can work. Okay. So now, how do we teach a robot what to do? Basically, instructions. We give the robots instructions using an appropriate language that robots understand. This language is called programming language, right? Okay. Now, what does a robot do in a nutshell? In a nutshell, any robot that has a task to do after it has been programmed, after the robot knows what it is expected to do. Take, for example, the medical robots I've shown you. All right. So basically, it starts and then you place the package is expected to deliver to a ward, let's say ward B. All right. So what happens? Can turn left, can turn right, can move forward. When it sees an obstacle, it stops. All right. After delivering, it returns. Okay. So these are actions to take for it to achieve the goal. Okay. So now, do you think a robot can guess? Do you think a robot can guess? Do we think a robot can guess? What do we think? Do you think a robot can guess? Okay, someone is saying no, robot can't guess. No, robot can't guess. Okay, no. All right, that's beautiful. Beautiful. Okay. No, it can't guess. You've all answered well, all right? So basically, it has to take decision, all right? It has to take decision. Now, what if in your instruction, the instruction you're giving the robot, you didn't actually tell it what to do when something comes up, right? Maybe you didn't tell it what to do when something comes up. For example, you didn't tell it the kind of decision it should take in certain events. So what will it do? All right. So for example, this robot, it is meant to sense obstacles. And let's say there is fire in front. All right. So is fire a rigid obstacle? Is it something that is rigid? Something rigid? Fire, you know. So do you think it can sense fire? Like when there is when there is fire, can it might not be able to sense it. It will want to walk right through, because at that point in time, it is not seeing any obstacle. All right. All right. Good. All right. So now, yes, someone has answered very, very correctly. But if it has heat sensor, beautiful, beautiful. And that is exactly how we make a robot more intelligent. Look, I can see Josiah and Joshua. Do you have any question? Okay, so that's exactly how we make our robot more responsive, more intelligent, by including other sensors that will make it better and smarter. All right. Okay. So robots do not guess. All right. So they have to follow your instructions clearly. Okay. All right. Okay. So now, for example, look at this. It is going from the pharmacy and then it has to deliver a product. Just imagine this scenario. The robot is going from a pharmacy, it has to deliver a product to ward B, right? And then there is something that is risky, something that can potentially damage the robot, or something that can potentially damage the quality of the medical component it is delivering. All right. So Now, what happens in this case? All right, based on your instruction, remember, whenever there is no obstacle, the robot should follow the path until it gets to the right word. So it will move forward. So what should it do now? Will it stop? Will it turn randomly? Will it detect the obstacle when there is no obstacle? What should it do now? So because it doesn't have the right sensors, that will make it to be limited. So in order to build amazing project, you have to think about how you can include various sensors that can make it smarter, right? But mind you, a robot must not be able to do every single thing, all right? A robot must not be able to do so. That's why robots have their applications, right? Robots have their applications. Okay, so now moving forward. Okay, so imagine you want to program a robot now. Imagine you want to program a robot, all right, for it to go from a pharmacy to the ward. Let's just tell it what to do. All right. So let's assume the dotted line represents the paths it has to follow. It represents the track it needs to follow in order to get to the word. All right. So let's just try to imagine we are programming this robot now. I want to tell it what to do in the phase of giving instruction. All right. So we start by saying, you can see move forward, right? So it moves forward. Then it gets to this point. What does it do? It has to turn. Is it left or right? Right, of course, because that's the way that leads to the word. So it turns right. Then when it turns right, what does it do? Does it just stay there? No, it has to move forward until it gets to this point, at which point it turns right, right? And then it moves straight to word B. And that is where it stops, so that it doesn't exceed the word. All right, so the order actually matters. It needs to know exactly which instruction is, in case there is a sequence of instructions, it needs to know which one comes before which one. All right, so now look at this. All right, so now imagine an obstacle is detected. From what I've explained, what happens? How does it even detect the obstacle? Right, it uses the sensor it has. Then it takes decision on what to do. So based on decision taking, it acts. All right. So that's basically the idea in a nutshell. The robot has a sensor, always scan the environment. Okay. Once it scans the environment, you find an obstacle, you decide on what to do. And once you've decided, you act. Okay. So the decision is based on the instruction given. Right. So what if we could build another robot? So we've come to the interesting part. So we are gradually coming to the phase where we actually have to build an actual robot. It's going to be virtual, right? It's going to be virtual, but we have to give instructions to an actual robot. Okay. So now what if we could build another robot? Now this is where we come into virtual robotics, right? So imagine having a robot, right, that actually responds to your instructions, right? But the robot actually runs in your system. It can carry out tasks, it can do a amount of things, but it runs in your system, right? So that is where virtual robotics comes into play. Okay, virtual robotics. Okay, so this virtual robotics can take so many forms, right? It can take so many forms. They could be RPA oriented. That means they could be robotic process automation. They could be automating processes, right? For example, do you know it is possible to build a virtual robot? By virtual, you cannot see it physically, just like we can see this one. You might not be able to see it physically, just as we can see this one, all right? But you only see what it is doing, right? So that is one form a virtual robot can take, right? So do you know you can create a virtual robot that can be able to automate tasks for you. Do you know you can create a virtual robot that can automate processes for you? Creating the robot, you install it in your system, and then the robot carries out instructions for you. This instruction could be, imagine you have 1,000 email messages. You need to respond to each of these mails. You can make a virtual robot. A virtual robot will respond to the mails, will give customized responses, not just generic jargons. No, it will give customize the correct responses based on your instructions, right? Based on your instructions. So based on instruction you've given it, it will give the exact, it doesn't make mistake, right? So someone is asking, do I have one of my own? Okay, I've worked on it, but I don't have one at the moment. All right, so I'm going to show you the tool I used to work on it. Now, what did I work on? Now, I created a virtual robot. I needed to do a study from a website, right? So I needed to collect data from a website, right? So what did I do? I knew that there's a lot of information, right? So I had to create a virtual robot to help me automate the process. So what the robot does is that it created an Excel column, it retrieved the various data, and it arranged it in the Excel column for me as I wanted. So those are the kind of things virtual robots can do. So that is one way, that's one form a virtual robot can take, right? Where it automates processes such as responding to WhatsApp messages, right? Someone might think you are the one responding without knowing that your robotic assistant is responding for you, right? Response to WhatsApp messages, answering mails, and doing a number of things, right? So when you install it to your system, what it does is that it's almost like your system has taken control of itself, right? So you see tabs open. It doesn't mean you want the robot to send an email, for example. After installing it and coding it, you just see it will just be like your system is operating itself, right? So you will see your cursor. Your cursor goes to where you have your Gmail app. It clicks it open, then it places the cursor where it has to type. It types, then it goes. You see your cursor moving to send. It clicks send, and and it's very, very fast. So that's a very interesting thing about robotics. So that one is an aspect of virtual robotics that you could use to automate processes. All right. Okay. So there is another aspect of virtual robotics whereby you can simulate an environment. You can have the robot itself, you can see it, but you cannot touch it, right? It will only exist in an environment, in a virtual environment, right? So when you program it to move forward, it moves forward. When you program it to move backwards, it moves backwards. You can use it to simulate a lot of things, stuff like that. Okay, so that is another aspect of virtual robotics. Okay, so now we are going to be working on it. We are going to be using our very first virtual robot today. All right, I will show you how to do it, how to program it, right? So it's not going to be the one that automates processes, all right? It's a bit more advanced, but we'll be doing the one that will exist in a virtual environment, and then we'll write programs to it. You will see it moving, right? Based on the program you've written. You want it to turn left, you see it turning left based on the program. You want it to turn right, you see it turning right. And you want it to pick up an object, we'll simulate all of that. It will pick up the object, take it to the right place, all those stuffs. We are going to be doing it now. Okay. So now, just before we proceed, so now, why exactly would engineers do what we are, why exactly would engineer do this? All right, so in order to create a virtual robot, all right, so why exactly? Okay, do you think so? It could be as an assistant, it could be they could do it to automate tasks like the one I did that helped me gather data from the internet and organized it for me. So it was able to gather so many data in a very short period of time. Right. So that's why. Then how? They build it, they write the code, they test, reset, change, try again. So these are the stuffs they do. Okay, these are the stuffs you are also going to be doing as prospective robotics engineers. I know that many of us are very much interested in the field of robotics. Okay, so it's time to build our virtual robots. Remember, our hospital robots. So we're going to be building our virtual robots based on the same kind of characteristics our hospital robot has. So we're going to be building our virtual robot. Okay, so now with, to start with, we are going to be making a robot that cleans up the environment. So we'll be having a coral reef, like under water body, that's the ocean floor, all right? We'll be having some waste materials there, and we'll automate the robot and we'll watch it clean up the waste. All right. Okay. So now let's get to work. All right. So I hope we are with our systems. I'm going to stop sharing for a moment and present something else. Okay. Can we proceed? Can we proceed? All right. Okay, beautiful. Okay, so I'm going to give us, okay, someone is asking whether you can use phone. Unfortunately, you can't use phone. You need to use a PC, a computer, but you can watch and follow through, all right, and practice on a PC later. It's a good thing that this video is actually recorded so you can practice on your own data. Okay, can we proceed? Okay, I would like us to take let's take 2 minutes break. Probably those that want to drink water or those that want to use the restroom can quickly use the restroom, and then when you get back, we'll go into building our very first virtual robot. Okay, I can see a hand up. Any question? Do you have any question? All right, are we ready? Can we proceed? Okay. All right. All right. All right. All right. All right. Okay, so I'm going to be sharing my screen. All right. Okay. Okay, so I'm currently sharing my screen. How many of you can see my screen? All right, beautiful. So the very first thing you have to do is open your web browser. So you can use your Chrome, you can use your Microsoft Edge, you can use your Firefox, whatever web browser you have will work just perfectly fine. So for me, I'm using Microsoft Edge. Okay, so what you have to do is, so on your Microsoft Edge or whatever web browser, using the search bar here, so you're going to type in Vex Code VR. All right, Vex Code VR. Okay. Now, what is Vex? Now, Vex is a virtual robotics company, right? So they do lots of virtual robots as well as physical robots. Okay. Now, they have graciously allowed people like you and I to use their simulation environment where we can write basic code and use their virtual robot to understand how the codes we've written can affect the robot and see the robot responding based on instructions we've given. Okay, so a very big shout out to Vex. Okay, so after writing your Vex Code VR, it brings you to this page. So you are looking for the link that says Vex Code VR, just like this. All right, so click this link and then it brings you to the environment. Yeah, so welcome to Vex, everybody. This is the environment where we'll be we'll be working with and coding our very first virtual robot. Again, I need to mention that this is not going to be the kind of robot that will be automating tasks like the instance I gave you earlier, whereby I did a robot that assisted me in retrieving some data from the internet. No, this is not going to be that. So this is just a virtual robot that will be programming and we'll watch it respond based on our code or instruction. So there are two ways to use Vex. You can either pay for it, for educators like myself, I get to pay about $199 per year. Another option is to use it for free. So I'm going to use free for now. Okay, so so this is the environment, right? So I'm going to get rid of this. If you are using Vex for the very first time, it will bring out this clean environment here. All right. So the very good thing about Vex is this: Vex is beginner friendly. All right. So some of us might be wondering already, oh, what if I don't know how to do any programming language? What if I don't know how to tell the robot what I want it to do for me? All right, so Vex has made it so easy that you don't need to worry about the programming language. So basically, Vex uses blocks. You can see block of code, all right, which you can understand easily. All right, so basically, how this block works is that based on the block of code, you drag and join right here. All right, so the robot is going to respond. So for example, we have drive forward. So our robot is going to drive forward, right? That's what it means. Okay, so that's what this block means. The blocks have been categorized into sections. So this is a drive. This one is called drive train. when you want the robot to move maybe forward or backwards, or when you want it to exhibit any kind of movement, right? So you use the drivetrain block. Okay. So when you want it to move for a given period of time, so here for a given distance, you want to specify the exact distance. So you use this second one. You want it to drive forward for 200 millimeters, for example. So you can use this 200 millimeters. All right. You can also increase the distance. You can ask it to move for 1,000 millimeters. You can also change the scale from mm to inches. If you are more comfortable working with inches, and you can use inches there. Okay, so that's that. So if you want it to turn right, you use this. You want to specify the angle you want the robot to turn, you can use this, right? So here you can manually type in the angle. You can say turn 180 degrees. All right, so it will turn 180 degrees. So we have other things, other stuff. Then for the magnet, if you want the robot to pick up an object, right? Pick up an object. Okay, so use the energizer magnet block, right? So basically, if you wanted to pick up something, you make sure boost is selected over here. All right. And then if you wanted to drop the object, you select drop. So that way you can be able to simulate your pick and drop robot, right? Then you want to do you want to make a robot that will trace a part, or that will paint something for you, that will write whatever, your name or whatever. So you can use this drawing category. So under drawing category, you have this, you have this, you have this, which allows you to set the color of your pen. You have this, right? So there are various colors you can actually pick from. So when you adjust this, you can make all sorts of colors. Okay, so you want to fill an area. That's the essence of this. Now, what is a robot without a sensor? Every robot must have a sensor. So Vex actually provided you with sensing abilities. If you want the robot to be able to sense when something touches it, all right, so you can use this. We want you to sense an object in front, you can use this. We want to sense when the left bumper is pressed, you can use this. You can use this to read distances before touching, coming close, right? So that's the distance sensing here. This is the bumper sensing, right here. Basically, the bumper is more like the front of the robot, right? Probably left or right. So just the area close to the body of the robot. So this is for the distance sensing. This is for eye sensing, all right? So you want the robot to actually see, probably to see color, maybe to detect brightness or whatever. You can use these blocks here. All right. So then under sensing, we can also sense location. All right. When you want it to go to a particular location, you can use this. All right. Then this is the console. You want it to print out something for you, clear all rows and stuff like that. Then this is a logic. It comes to decision making. Remember, a robot should have intelligence, right? We mentioned it. All right. So when you want to tell the robot how you want it to respond to, based on what it senses, you want the robot to probably wait or do something a given number of times, right? You want it to repeat an action 10 times, for example. You want it to do something forever without ever stopping. You can use this. You want it to repeat until a certain condition is made. All right. So you have all the blocks right here. So you have the timer. You want to have control of the time. You have the blocks here. You have event blocks. You want the robot to do some maths, is also possible. You want the robot to compare things. You want the robot to think mathematically. You can use these blocks here. All right. Then you want to make a variable. So variable robots should also have memory, right? They should be able to store information. All right. So you want to give your robot the ability to store information, that's where variables come into play. So you can use custom-made variables. Robotics have provided you with some custom-made variables. You can use them. You can also decide to create your own variable by choosing make a variable right here. Okay, so the variables can be forms, Boolean, list, etc. But some of these concepts together to okay. Now, what about comments? If you want to write comments on your code so that other prospective programmers can read your code, use it, edit it, and understand the code, you can use comments. Okay. Now that we've had a rundown of the various block categories that Vex makes available, it is time to code our first virtual robot. Okay, now where are we going to be simulating our robots, right? So Vex also makes provision for that. Now you can select, there are various playgrounds. Vex calls it playground, where you can use your robots, right? So for example, you want to do art. This playground allows you to use your robot to do art, right? So I'm going to select this one, for example. So I wait while the playground is being loaded. So look at this. Now, this object you can see here is our virtual robot. So it's going to be responding based on the code we place here, based on the code instruction we give here. It's going to be responding. So basically, if you want it to start responding, you click the play button. You want it to restart, you click this. Now, if you want to change how you see the robot, you can click this. All right, this way you will see only what the robot is seeing, more like you are seeing through the eyes of the robot. You want to see the robot from the top, you do it this way. You want to see the robot from an angle, so this is your virtual robot. So you can see what the robot looks like. All right, so you are not making this robot. Vex has already provided you with a virtual robot. So your objective is just to write your codes and watch the virtual robots act or respond based on the code or instruction you have given. All right. So now let's see how, let's just do something basic, right? So I'm going to, okay, someone is saying I can't go in. Is there any, what exactly is the challenge? Okay, you're not able to open the environment. Do you have a stable internet connection? Okay. Okay, so I guess we'll continue. All right. Let me know if you have any challenge. Are you able to access it now? Oh, he says he sees codes, a code. Oh, all right. How do we? Okay. Do you mind? Can someone share his screen? Can you share your screen, Richard? Are you allowed to do that? Okay, I can see a hand. Dominic. Okay, please share your screen. Let me see what you mean. Okay, so for the others, while I attend to Richard, feel free to play around with your virtual robot. For example, you can drag and drop this right here and ask it to move forward for maybe 1000 milliseconds or whatever, 10,000, and see it work. So when I click play, you can see it starts moving. Whoa, it bumps into the obstacle.
It looks like
Feel free to play around with it and see what happens. You can do turn left, turn right, and so on and so forth. Okay, I'm seeing says enter class code or team number. Please, you have to cancel it out. Okay, cancel it out. So scroll down and select a playground that doesn't require premium license. Scroll down. Yes, you can select art canvas, for example. Yeah, so Vex is not completely free. Okay, so while it gives us the access to some of its features, you also have to pay in order to access the full premium package. Okay, so now we've sorted. Kindly stop sharing your screen. Thank you very much. Now we are going to the subject of the day. We are going to be making a coral reef cleanup. Okay, we are going to be making our coral reef cleanup. All right, so now close this boring playground and click to select another interesting place. So we'll look for a playground called Coral Reef Cleanup. So this is it. So select this Coral Reef Cleanup playground right here. Okay. All right. So we select it. Yeah. So the playground is loaded right now. So this is more like an ocean floor. It's a coral reef. All right. So I can view it from various angles. So basically, this is more like an underwater robot. All right. An underwater virtual robot. Okay. So the idea is to write a code that will enable this robot to continuously search for waste materials. For example, when you look around, you are going to see some trash, some rubbish materials. Now, this is a plastic container right here. The yellow plastic container is there. So this one, I don't even know what this one is, but it is a waste material. So you can see the plastic bottle right here. You can see, let me zoom out a little bit. You can see this one. I don't know what this one is. Probably a box or something, a trunk or something. So now, can we write a code that will enable this robot to automatically search this ocean bed and get rid of them? All right, so it will get rid of them. Okay, so how do we do that? All right, so how do we get that done? Okay, so how many of you have been able to load this playground? How many of us have been able to load the playground? All right, beautiful. I can see hands. I needed to be sure that we are following. That was why. Okay, I'm going to return to sharing my screen. All right. Okay. All right. So now, the first step we are going to take is this. We have our when started. If for any reason you can't find this when started block, all right, so all you need to do, you don't have to panic. You click logic. And when you come to logic, you scroll down until you find the when started block. Then basically it's drag and drop. So you drag and you drop. How am I able to drag it? If you are using a trackpad, which I believe most of you are, all you need to do is you take your cursor across the block you want to place on the canvas. This is a canvas right here. So you take your cursor to the block, then you hold down the left button of your trackpad and you drag. So the moment you release, it will be placed there. All right. So if you want to delete, all you need to do is you click the object you want to delete, and then you click the delete button or backspace button of your keyboard, and it goes away. Another smart way of deleting is this. You can simply drag the object and then drop it right here where you have the list of blocks, and it simply goes away. All right, so I'll place my when started block on the canvas. All right, so now I'm going to, now I want the robot to keep searching for the waste materials without ever stopping. So what I'm going to do is I'm going to find my forever block. So forever block is found under the control section right here. So I will drag my forever block and I'll place it right here. Okay. I hope you can see my screen. I'm trying to make it a little bit bigger so that everybody can see. Okay, I will just drag this playground a little bit to the right so that we'll have more space. Okay, now the next thing we are going to do is, now we want to say when started. So basically, when started simply means, what does it mean to start? It means to click the play button, right? So once you click the play button, you have started, all right? So remember, the robot is going to respond exactly based on the instruction we provide right here. Okay, exactly based on the instruction. So we say when started, that means once I click this play button here, that means I have started. Now, forever means basically the robot has to do a certain task forever. Now, notice something very, very important. Now, I could simply say, I could come to drivetrain and drag and drop forever right here. Okay, so you can place something within the forever block. What this means is that whatever you have right inside this forever block will keep on, the robot will keep on doing any instruction that is found within this forever block. The robot will keep on doing it forever without ever stopping. All right, so now when you put this and then you click the play button I have over here, I'm going to drag this way, and I click the play button. You can see what's going on. The robot keeps going forward until it meets an obstacle. All right, so it is not allowed. The idea is that we are not allowed to damage the coral. We are not allowed to damage to cause harm. All we are required to do is to clean the ocean bed. All right, so I'll cancel this out, and then I'm going to take away this, since this is not what I want. Now, what do you think will happen? I will click to restart. What do you think will happen if you place turn right here and I click play? Can someone guess what will happen? Okay, I'll just go ahead and click the play button. So I click play. Look at what's going on. The robot is continuously turning right without ever stopping. So that makes it keep moving in circles, because it's trying to obey your instruction, your command. You can see robot. So it will keep on turning until its battery runs down. You can see what's happening. The battery is constantly running down. Remember when we talked about a robot requires some sort of energy to be powered. And at the same time, notice that the waste materials in the ocean bed is building up, right? So the robot is not being effective this way, okay? So we are going to stop this and then we'll try to make our code. Okay, now I want the robot to turn right, right, in order to search for a waste material. Okay, so now what we want it to do is it will keep on searching, all right, until it finds a waste material, all right, until it finds a waste material. So how are we going to do that? So we go to logic, then we find this block that says while. So we place it right within the forever block. Then we go to our sensing right here. So we are looking for distance found an object, right? Distance found an object. So this is it right here. Notice that if I click this, okay, hold on. I'm looking for something else. Found an object. Okay. Okay, so I'm looking for, we want to be able to find the object. So I come right, okay. Okay, so it's still okay, So we can still use this block right here. It will work perfectly fine. So look at this. I can place this block right here. So basically, front distance, that doesn't matter. That's perfect. Okay. So now look at this. When I put this here, so what it's going to do is that whenever the robot finds an object, while it finds an object, it's going to run or behave or carry out the instruction I placed right here. But now I want to do something a little bit different. So I come to logic and I look for knots. Okay. So when I place this within the knot, and then I place this right here, it means that the instruction here will be carried out while the robot does not find any objects, all right? So what do we want the robot to do while it has not found any trash yet? What do we want it to do? We want it to keep searching until it finds a trash, until it finds or detects a waste material. All right, so we are going to implement that. So basically it needs to search for the waste material by turning round and round and round. So what we are going to do is we find under the drivetrain, we want to tell the robot, hey, you have to turn right. So it keeps on turning right, and as it's turning right, it is sensing an object. So whenever, if at any point it turns right and finds an object, it will now proceed to carry out the next instruction. Okay. Now the next thing we are going to do is, so we've been able to handle what happens why the robot does not find an object. So the next instruction we are going to give is to tell it what happens when it finds an object. And in this here, we are going to be using a variable, a very important variable. Now, we are not creating our own variable. There is an existing variable that says drive to garbage. All right, drive to garbage. So now, whenever the robot finds a garbage, it is meant to drive to the garbage. All right, so want to set it to drive to garbage. Okay, If I place it here, that would be wrong because this block controls what happens while it has not found any object yet, which is towards to keep searching by turning right continuously. So I have to place it outside here. So whenever it doesn't find an object, it will not execute this loop here, this while block here. It will go straight to this area. So while the object finds an object, while the robot finds an object, it should drive straight to the garbage. Okay. Now we need to specify. We need to specify the. We need to tell it what to do. Okay. What distance do you want it to drive? Very important. Then in that case, we have to find the area that allows us to explore the distances. Okay. All right. Okay. So this is it right here. Okay. So we want it to drive a certain distance. How do we specify the? We don't just put the distance here. It's important. It's important. Oh, someone is saying how long left? How long left? I believe that's what you are trying to ask. Or are you saying how about left? You can actually search by turning left or turning right. It will work just fine. Someone is saying I can't see the drive to garbage in the variable option. When you get to the variable option, under the when you scroll down, can you see any variable that's called drive to garbage? Just right below the make a variable. Okay, someone else is not seeing. Did you select? I hope you selected this, the coral reef cleanup. Did you select this? Okay, someone is saying I can't see the drive to garbage in the variable option. Is the coral reef selected? Okay, is responding by saying yes. All right. Now, the good thing is that you can also make a variable. That's not bad. That's totally okay. So click to make your own custom variable. Ensure you spell it out as it is written here. So I'll just click and then you have to type drive underscore drive. Do not leave spaces, please. Drive underscore two. Two should be small letters, underscore, then you write out garbage. Right, so you can create a variable like this. Since you can't see, I can't create this variable because I already have the variable. So since you don't have the variable, when you create it, it is going to work. Are you able to create a variable now? Okay, someone is saying, I didn't see this particular playground. When you click open playground, so I'm going to close this for a moment. When you click open playground, click select playground here. And when you scroll down, you are going to see coral reef cleanup. Coral reef cleanup. So under the select playground, you should look for coral reef cleanup. Okay. So it should be there. All right. Thank you. You're welcome. Okay. So let's go back to open our playground again. So I believe you found your variable, you've sorted your variable, right? Okay. So now we are going to say front distance. Okay, so we need to specify the exact value of our front distance. Okay, so we go to under. Okay, okay, beautiful. I'm glad to hear that it's working now. That's amazing. Okay, that's lovely. Okay, are we continue? Okay, hope we can continue, right? All right. All right. Okay. Okay. So we can place this, right here. Okay. So we can place this right here. And then having done that, we can simply do what? All right. So when it doesn't find when it finds the trash, then what can we do? We can ask it to drive. So we have set drive to garbage a certain distance. Okay. So now it's important we specify the value. Okay. So it's important we specify the value. So we have to place it. We want to specify a certain value. So we can put this here. So it's going to increment, it's going to drive a certain distance, right? 25. So what does this mean? It is going to keep on doing this until it gets to that particular place where the garbage is. So I'm going to place this right here. Okay. Now, finally, I'm going to ask it to move. So I go to my drivetrain and then I want to select drive. I want to select this, place this right here, and then I come back to my variable block by scrolling this way. Then I want to select this and I want to place it right here. With that, we have our code that will enable the robot go ahead and clean the coral reef. So I'm very excited to test it out. So let's see. I'm going to click the play button right here and then it starts moving. So can you see what is happening? So it's moving to the waste and somehow it is removing the waste. So let's see how much waste the robot can remove before the battery runs down. So I can view from top, I can view from the side. I can even view to see what the robot is seeing. Let's see how much waste the robot is able to remove before the battery runs down. Okay, someone is asking, how did I put the blue and green blocks together? Okay, here is how I did it. Okay, so now basically, so I'm going to stop this for a moment in order to answer your question. I'll just stop and then cancel this out, restart. Now, all I did was I scrolled down and then I found this, right? Then I scrolled up and I got my front distance in this. Then when you take this object close to this place now, it is going to be highlighted. The hole will be highlighted. Can you see that? when you take the object close, when you take it close to this place, the hole will be highlighted this way. Can you see? And then when you leave your mouse, it gets joined like this. So try. Are you able to do it now? I hope that answers your question. All you need to do, get a block. Just take it close. When you take it close, place it right, you get it. Okay. All right. Someone is saying my robot isn't moving. Why is it not moving? What happened? Okay, do you mind sharing your screen? Jane, do you mind sharing your screen? Oh, you can't share your screen. Oh,
Jen can share now. She's not a co-host.
are
Jen,
you
go
sure
ahead.
you did
Yeah, she can share.
everything I did exactly?
can share.
Exactly. Because it's supposed to work. Oh, okay, I can see your screen now. Oh, hold on, Jane. Are you the one currently sharing? Okay, so you didn't do exactly, your code is not exactly how mine is. So first of all, this I'm going to delete it. So first of all, this set drive to garbage, all right, it shouldn't be inside the while loop. It's meant to be outside right here, not here. Your code is currently like this. Your code is currently like this, but it's not meant to be like this. It has to be right here. Do you notice a difference? So you simply drag this out and place it right here. You can try that now. No, no, not there. No, not there. Down, no. Okay. No, yes. You are still putting it in there. No, 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 no. You are still putting it in the wrong place. Drop it. Good. Now drag from set drive to garbage. Take your cursor. Yes. Now drag it down. Good. Now take it up a little, just outside the while loop. No, drag the both thing. Yes, two of them. Exactly. Up. You're not placing it there. Yes, there. Yes, there. Correct. Now try running your code now. So you can see that it's working now. Okay. All right. Who is the next person that is meant to share his or her screen? Okay, Chim Harida. Are you sharing your screen now? Please share your screen, Chim Harida. Okay. All right, that's perfect. Okay, Chim Harida said she has done it. That's perfect. Okay. Okay. So that's exciting. All right. So now that we've gotten our code, let's click the play button and watch the robots clean up the coral reef. So I'm going to start. So I want to see how many kilograms of trash my robot can collect before the battery runs down. So I want you to run your code and let me know how many kilograms of trash your robot was able to collect before the battery runs down. So mine is currently in 11 kilograms and the battery is around 76. Okay, I've gotten to 18. Okay. All right. Oh, my robot battery has gone quite down. Now in 27%, 26. But wow, I've gathered a lot of waste. Oh, my battery has gotten quite low. The battery of my robot has gotten quite low. Let's see if it can make it up to 60 kilograms. I hope 59. Oh, he made it 60 kilograms exactly. That is interesting. So the good thing about Vex is that once you are able to write a code that successfully um, cleans up the coral reef, you have the option of getting an actual certificate from Vex. Isn't that amazing? So let me know before we grab our certificates just from the coral reef cleanup, right? So let me know how many kilograms of waste was your robot able to gather before the battery runs down. Jane, how many kilograms of waste did your robot gather? You can see mine is 60 kg. Okay, not done. Whoa, Ayo Demi Lade. You were able to gather, whoa, someone gathered 64 kg. Wow, interesting. Someone even got up to 79.5 kg. That's a lot. Beautiful. That's lovely. Wow, someone has 62. I think my robots gathered the lowest waste I've seen so far. Someone gathered 62, another person that Obonna Claire gathered 62. Someone else gathered 64 kilograms. I'm seeing 79.5. That's a lot. That's interesting. Okay, I'm waiting to see more responses. All right. I guess some of our robots are not yet done. Whoa, okay, I can see Chimarida Dominic, 63.5. That's amazing. Okay, Now, when I see one more person, then we'll go straight to grabbing our certificates for the coral cleanup, coral relief cleanup. Okay. All right, I think we can just continue. So in order to get your certificate, what you have to do is you click get certificate over here. Can we still see my screen? Oh, all right. So you click get certificate over here, and then it would take you automatically to a page where you can get your certificate. So this is a nice certificate from Vex, right? So Vex is giving you a certificate because you are able to get the coral reef cleaned up. So here you can go ahead to type in your name, and when you've done that, you can click generate certificate, and then it generates your certificate right here for you. So you can see mission complete, Ajokole with Miracle, right? And their VR ocean cleaning robot have successfully cleaned 60 kilograms. Okay. So now I can actually click to download my certificate. I can save image. Once I click this, I can save image, or at least I can click it again and get my certificate. So here I clicked get certificate, and then it brings me here where I can safely download my certificate. So when I click the download button here, I can click to save my certificate. So I can simply call it whatever I want to call it, and then I click save. So make sure you take note of where you save your certificate so you can show your parents. And that was the certificate you got from making a virtual, from writing the code for a virtual ocean cleaning robot. Okay, now I want to show us just one little thing. Okay, so now do you know we can actually possibly increase the kilograms of the waste cleaned by trying to make our robots move faster? So let's try to make our robot. It's possible to make the robots move faster. That way it can gather as much waste as possible. So how can we make the robot move a little bit faster? So what you can do is you scroll, and then you should find the area that lets you set drive velocity, right? So want to set drive velocity to a certain value. Okay, so we basically drag this, we're looking for set drive velocity. Yeah, so this is it. So we place this right here, and to give it a maximum velocity, you can use 100% if you want. A number above 200 is actually allowed, so you can use your set drive velocity. Also, you also want to set turn velocity. So you want to set turn velocity to a value of 200% as well. So with that, your robot should be able to move a little bit faster. So again, I'll open my playground and then I'm going to hit the play button. Whoa, look at that. The robot is now moving faster. Can you see that? So with this, I believe I can be able to collect more weight than before. Isn't that amazing? All right. All right. Okay. Oh, okay. Someone is saying, Ikechukwu Okoli, you are saying e-speed makes it bump into walls a lot more. You can consider um resetting the speed or something. And with this, I'm able to collect less waste because while the speed is higher, it also affects the battery. That's why. So while the speed is higher, the battery drains faster, right? So which also talks about energy. So you have to be conscious of your energy, right? Energy is a very, very important factor when you are building your robot. Someone is asking, can you print it out? Of course, you can print out your certificate. Once it's downloaded, you can go print it out and hang it in your room so that whenever someone comes in, you show them that you're able to clean lots of waste using your virtual robot, the very first virtual robot you made. Isn't that amazing? All right, so I'm going to give you an assignment now. So I'm going to give you an assignment. So here is the assignment. Okay, so I'm going to close this. So the assignment is simple. All right, the assignment is simple, a very simple assignment. So here is what your assignment is about. So you are going to select this playground, select this art canvas playground. So when you select it, all right, so I want you to use the art canvas playground to write any 3 letters of the alphabet, any 3 letters of the English alphabet. So you write letter A, for instance, you want to do A, B, and C. You can write letter A, you can write letter B, letter C. So let me show you what I mean. So with this, I'm going to show you what I mean. For example, now, let me just make a letter for you. Then from my example, you can make any other letter of your choice. But please do not do the letter I am doing, right? So I'm going to make letter, let me make letter H, all right? I'll make letter H, okay? So I will just grab the, and by the way, you can actually save your code, right? So this is very important because you might need to save your code, okay? So I'm going to show you how to save your code quickly. I'm going to show you how to save your code quickly. All right. So now, because I need to make a comment so that you can remember that this code actually works with a coral reef cleanup. So I'm using my comments now for the very first time. I'm showing you how to use comment for the very first time, right? So this is the essence of comment. For you to understand what the code does, should you visit it after a long time, so you can all be able to understand what the code does. So I'll use the comment and I'll write this code enables a virtual robot. VR means virtual robot. You can spell it out if you want. Virtual robot to clean up a coral reef. All right. It enables a virtual robot to clean up a coral reef. That way, when you open the code, you will know what exactly the code does. You can even make a second comment by saying, please select the coral reef cleanup playground to before running. Sorry, before running the code. All right. That way you will remember to select, you remember to go here and select your coral reef cleanup, all right, before you run the code. All right. So with that, we are ready to save our code. So you can simply put this comment right here. It doesn't affect the code in any way. The code will work perfectly as expected. So now I'm going to show you quickly how to save your code. In order to save your code so that you can be able to use it next time, what you have to do is you go to File, then you want to select Save. So once you select Save, it's going to open your File Explorer. Can you see my screen? You can't. I'm going to share my full screen so that you will see that it opens my File Explorer. So I'm currently sharing my full screen now, so you can see the moment I click File and I click Save, it automatically opens my File Explorer. Another way to do it is you can click Control S on your keyboard. It automatically opens your File Explorer. So now you are going to select any folder where you want it to be saved, right? I think you should make a new folder, probably in your desktop or your documents. You can make a new folder probably in your desktop or documents. So I like to make my folder in my desktop so that once I'm in my desktop, I can easily see it. So feel free to make your folder anywhere you can easily find. Now, I'm going to rename it as. If you like, you can use my first virtual robot. You can spell it out, virtual robots. So you could also put coral reef cleaner if you want, and then you can go ahead to save your. Remember, we are saving it in a new folder. So I can call my folder, I can call it Sismo robots or Sismo boot camp if you want. Again, please feel free to use any name of your choice to save this project. So I'll select Sismo Bootcamp folder. I'll open and then I will save it right inside the Sismo Bootcamp folder. Now I can be sure that my very first robot is successfully saved. So that next time, if you want to open it and play around with it, you can simply go to File, then go to Open, and then you can find it in your desktop or depending on wherever you save it under the folder Sismo Bootcamp. All right. So now I can drag and just discard all of this without worrying because I know that I saved this successfully. So I can discard all of that. And then for the assignment, a quick explanation. I said you are making a robot that can write any 3 letters. Okay, any 3 letters. All right. So now, why are we making a robot that can write any 3 letters of our choice? Okay. So basically, we want to be familiar with the idea of the program. The idea of the program is around energy, right? It's centered around energy, okay, and environmental health, okay, stuff like that. All right. Now we want to be able to familiarize ourselves with how to make this virtual robot so that we can apply it effectively, all right, when we want to make an actual robot, okay? So that's the idea. So now I want to quickly show you. So you are going to select a playground for your assignment, and I said you should select your art canvas playground, and then you are making any 3 letters. So I will make letter H for you. I don't expect it to make letter H because I'm using it to illustrate. All right. So all I need to do is I go to my drawing. I can, oh, someone is asking whether it can leave. So I'm just about to show you how you can do your assignment before you leave. So if it's okay, can kindly wait for like 5 minutes and then I should wrap up in 5 minutes if it's okay. But if you really need to leave, then it's fine. But kindly make sure you do your assignment. I would like to see your assignment in our next AI and robots course. Okay, so you want to move down and then you want to drive forward. Okay, then when we play this, look at what it does. It keeps driving forward. That means I need to specify the distance, so I can use this and say drive forward 200. So I think I want it to be 300. Then again, drive forward 300. Then I want it to turn right 180 degrees. 180 degrees, which of course can work. So when I play, it drives, turns right. When I restart, drives forward, turns right 180 degrees. Then I can still use another drive forward for 150. 150. Sorry, I want to drag this a little. 150. And when I play that, it moves. You can see that. So let's try again. So it goes, turns, moves. Then now I want it to turn right for 90 degrees. And then it should drive forward 200 All right, you should turn right 90 degrees again. So let's see what happens. It goes, comes here, goes here. Now I want it to drive forward 150. So that's how you do the assignment. You think like a programmer. So it drives right 150, drives forward 150. Then it can do a 180 degree turn, 180 degree turn, 180, and then it should drive forward 300. So let's see whether this can write letter H. So when I click, it goes, and there you go. Okay, so this is your assignment. Now, your code, there are so many ways of doing this. For example, I could still just use any method of your choice. I could take away the some codes that are not so necessary here. For example, I could remove this. Anyway, so whatever method, this code can be made shorter, just in case, just so you know, it can be made shorter. But feel free to write your code the way you want. This is mine. So this is how you can write a letter. So written letter H. You can see that. All right. So with that, can you see my screen now? Someone was saying you can't see. Can you see my screen now? Okay, so with that, I think we have come to the end of today's AI and robotics session. I hope you had fun. I hope you were able to understand all I said. I hope you were able to follow through. Thank you very much for attending. Do enjoy the rest of your day. Thank you.